When we look at the hybridization of a molecule like CCl4, this is carbon tetrachloride, what we're trying to do is we're trying to figure out the atomic orbitals on that central carbon here, how they mix and form hybrid orbitals, and how those hybrid orbitals then overlap with other molecules, like the chlorine atoms. The short answer here is that CCl4 has sp3 hybridization, and there are two fairly quick ways we can figure that out. The first is we can look at sigma bonds and lone pairs. So sigma bonds are single bonds. We have 1, 2, 3, 4 single bonds on the carbon atom between the carbon and the chlorines there. 4, that's the sp3 we're talking about. We could also look at what's called the steric number. So for the steric number, we're looking at the number of things that are bonded. We call them electron domains or electron regions on the central carbon here. We have 1, 2, 3, 4 atoms bonded to that central carbon. Because of that, 4, that gives us sp3 hybridization, just like we said before. Note that to figure this out, we do need to start out with this Lewis structure. So this is the Lewis structure for CCl4. If you need help with that, there's a link at the end of this video to help you with that Lewis structure. The process we used here, looking at sigma bonds and lone pairs, or looking at the steric number, it works pretty well. There are some exceptions. There's a link in the description if you want to look at those. But keep in mind what we're trying to do here. We're looking at the central carbon atom, and we're trying to figure out how the orbitals on that central carbon atom, atomic orbitals, they mix to form hybrid orbitals, and then they bond with these chlorine atoms here. This is Dr. B with the hybridization for CCl4, carbon tetrachloride. Thanks for watching.